this is the classwork, and your quiz that you're going to have covers the same topics, but it's not going to be exactly like this. If you notice at the top of your page, it actually says AP Stats Chapter 11. It looks like a quiz, and it is a quiz from the book. But the quiz that I'm giving you next week is in a different format altogether. So it's not going to be identical, but covers the same topics. So in this particular problem here, a teacher wants to know how students in her school feel about mathematics courses. And she decides to administer a survey to a random sample of students, and here are the different methods that she's chosen. So for number 1, 4 ranks of students, freshmen, sophomores, juniors, seniors, 15 from each class rank. What kind of sample is that? That's a stratified, I agree. So that's a stratified sample. We're actually going to say stratified random sample, just to make sure that we are using the correct verbiage there. How about letter B? Randomly select 10 math class sections and survey every student in each of those sections. What's that going to be? That's a cluster. Remember what I said earlier about a cluster is that you survey everybody in each of those groups. So that is a cluster sample. Good. How about letter C? Each student has a 9-digit student number. They randomly choose 60 different 9-digit numbers and survey the students that correspond to them. That's an SRS. When you number everybody and then randomly select the numbers. Okay, that's what we're looking for. D, randomly select a number from 1 to 5. Using the class roster, start at that number, then select every 5th student from that list. Systematic, when we also randomized our starting point here. So that's a true random good sample. So that's a systematic sample. Good. How'd we do? Get them all right? Woohoo, we know our definitions. Excellent. All right, number 2. We're still interested, the population of interest is still all the students in the school, but this particular teacher just surveyed the students in her class. Remember, she's a statistics teacher, so she only interviewed the statistics students and got their opinions on math class, on their math class. What kind of sampling is that? It's not stratified. It's convenience, because it's just her students, right? She didn't make any effort to go out, do any kind of randomization, do anything. It's a convenience sample. And I can never spell convenience. Those of us who are specialty spellers, did I do it right? Yeah. Katie and I were both like, I don't know. I come before E except after C, except for way and nay. I don't know. Are you criticizing my dot? All right, I didn't do my homework. Go ahead. What does a convenient sample always suffer from? What kind of bias? Undercoverage. Convenience is a type of sampling that suffers from undercoverage bias. It's a type of sampling that suffers bias. Yes, that's true. Okay? A convenient sample is a type of sampling that always suffers from bias. So it's probably why I put it on the bias section, because it is just a biased form of sampling. Okay? Good. Now, number 3. In this particular one, you can have 2 possible answers. I'm going to tell you the answers I got. I picked, and I'll tell you how I got them in a minute, but I picked Deidre, Chris, Rob, Eric, and Stacy. Did anybody else pick those numbers or know those names? 3 or 4 of you, 5 of you, okay? 6 of you. One might, so the other possibilities would have been Dick, Dave, Sarah, and Adam. Anyone get those? The other ones could have been Peter, Ellen. Anyone start there? Anyone get those? Okay. So what it depends on is how you numbered your people. Okay? I numbered them 0, 1 to 20. And that means I'm going to have to ignore some double digits. I'm going to ignore 0, 0 and 21 to 99. Would you agree? If you started and you numbered 0, 0 to 19, that's okay. I have no problem with that. Then you would just ignore 20 all the way to 99. That's okay. That's fine. All right? So you just have to tell me what you're doing. So what I'm going to do is I'm actually going to put those numbers in the boxes themselves. Okay? So let me just try to get this so I can do that. So I'm going to say that Adam was 01, Chris was 02, so forth and so on. Are we okay with what I'm doing? So 06, 07, 08, 09, 10, 11, 12. 13. Yes, love? Let's go through. I'm going to do it exactly so you see. Okay, you might be right. I don't know. Let's look. All right, so what's important, not only am I ignoring numbers that aren't numbered here, but what else do I have to be careful of? Once I've picked somebody to be sampled, can I pick them again? So I'm going to have to ignore what? Repeats. And I don't think repeats happen here, but you still need to say it. Okay? So that was something on your ESP investigative task. You had to say the words ignore repeats. And if you didn't, you got a point taken off. Okay? All right, so let's go through our sampling here. We're going to look at 2-digit numbers. And if you notice, I'm going to circle the first two, 04, which means that's Deidre. She got picked. The next two numbers is 02. According to mine, that's Chris. How are we doing so far? Now I'm going to look at the next two. That's 85. I cross it out. The next two is 52. I cross it out. Keep going. 59, 81. 18 is the next 2-digit number that I can use, and 18 is Rob. You have to make sure that you're crossing them out if you are ignoring them. Okay? And we'll keep going. We have 84, 07, that's going to be Eric. And then I'm going to keep going, 60, 20 is my last one, and that's Stacy, so I can stop. I've picked 5. So that's, to me, this is going to be an okay way for you to sample. And this is truly an SRS. Why is it an SRS? Because I've numbered all the students and I've randomly picked the numbers using a table in this case by ignoring the ones that don't matter and ignoring repeats. You will have to do something similar on your quiz next week, okay? Where you're going to be using a random number table and or you could use a calculator. We'll look at an example of that maybe later, and we're going to pick out some numbers here. But it's important to tell me what you're doing. How did I number the people? Okay? Any questions about that? You okay with that problem? You sure? Esmeralda, you good? You good? Make sense? All right. My second block class had some issues, but y'all are okay? You sure? Okay. All right, last question here on the practice quiz. We have 2 different kinds of bias here. What if the statistics teacher just decides, instead of randomly selecting students, she just asks students to volunteer? What's wrong with that? Because voluntary response bias, only people that really like math or really hate math are going to answer. People with very strong opinions. So that suffers from voluntary response bias. Say that again. One type of bias? Yeah, the one that's most prevalent. And there could be, you could argue for others, but this is the one that's obviously correct. Gives a survey during class one day. What's wrong with that? It's going to suffer undercoverage because, because not everyone's in class. One class is not representative of everybody, therefore, it's a convenient sample, right? So because it's a convenient sample, it's going to suffer And I know I spelled that wrong again. I really don't know how to spell it. Convene? No. Convenience? No. Right? Convenience? I don't think y'all are right. I think that's right. What, love? Who said it? Go ahead. Calling me out because I can't spell. There's no A, I know that. I did have it right? It's a convenience sample. Be happy with it. Suffers from undercoverage. Okay? Good. Thank you for the spell check. All right, I know, I'm terrible. I'm one of those who have to look at the word, and even then it looks funny. I don't know. Anyway, any questions on what's on your quiz next class? Because we're about to add the last part of the vocab on this unit. And it's not on your quiz, but there is more to this unit. Okay? Why is there more? Because it's part of it. Anybody in this class take IB Psych out of curiosity? Or has taken it or is currently taking it? 4 of you. Okay, 5 of you. You're not sure if you took it, or you took some kind of psychology class. That's fine. The next part of our data collection unit is called experimental design. And that is something I know you did in IB Psych. And if you did it in IB Psych, you probably know more about it than I do, to be honest with you, because they really go into it, whereas we just kind of brush on it and touch on it a little bit. But this is, again, some more vocabulary. So, again, you want to add to your note cards if you're making note cards. It's not on Monday's quiz, though, okay? Monday's quiz is only on the survey stuff and bias. Are we okay with that? Okay, just want to make sure. You feeling okay? You sure? All right. Not yourself today. I don't know, you're quiet, reserved. Worried about you, that's all. All right. So it's a lot of vocabulary. I don't really have a way for you to divide up your paper like we did last time, where we talked about sampling methods on one side and bias on another. This is just kind of a lot of vocabulary. But these are the first 4 vocabulary words that we're going to discuss. Okay? Experimental units, another word for that would be the subjects. So they're really kind of synonyms, okay? Experimental units and subjects are the people that receive the treatment. And I believe that was an EI, right? I don't know. It's one of the weird ones, right? Anyway. So what makes an experiment is when you have a treatment involved. Okay? So a treatment is what makes an experiment an experiment. And we're going to look at an example in a few minutes that deals with weight loss programs. But you probably have seen the commercials that say, you know, if you have this particular disorder, call and be a part of our experiment and whatever, and they try to do different treatments. Medical experiments are something that, you know, has to happen in order for a drug to be approved by the FDA. And we can talk about placebos and things like that, and we'll probably add that to our list of words as a placebo. Have you guys heard that word before? What is a placebo? I would, yeah. A sugar pill? What is a sugar pill? No, well, there is something called a placebo effect, believe it or not, but we don't think there's going to be an effect. It's like a fake treatment. It's like a pretend treatment. People think they're getting a real treatment, but it's not. So it's just, I just call it a fake treatment. But yes, a sugar pill is an example of a placebo if you were using if it was a medical experiment. But there are placebos in other kinds of ways as well. Okay? So again, a treatment is what makes an experiment an experiment. And in a few minutes, we're going to talk about the elements of really good experimental design. But it could be a poor experiment, and as long as you give a treatment, it's considered an experiment. What you are measuring in an experiment is called the response variable. So it's what you're measuring, what you're looking at in an experiment. What are you measuring is called the response variable. So if I'm going to use weight loss as an example, what would I be measuring if I wanted to do a weight loss experiment? I'd be measuring what? The weight. How much weight they've lost over time. And that would be the response variable. Almost always quantitative, okay, because it's a measurable thing. Now, factors is something that is controlled by the person that's conducting the experiment, okay? Often you find combination of factors to get all the treatments, but we'll talk about that a little bit later on, okay? There's another word I want to add here, and that's called blinding. You can have something called single blind or double blind. Blinding simply means that the subjects of the experiment don't know what treatment they're getting. So if we think about what Byron was suggesting with the sugar pill and the placebo, if they don't know they're getting an actual treatment or if they're getting a placebo, that's called blinding. They just don't know. They don't know whether they're getting the real treatment or not. So the subjects are unaware what treatment they're getting. What do you think double blind would be? If single blind is when the subjects don't know, what do you think double blind is going to be? Exactly. When both the people that are giving out the pill and the people taking the pill don't know. So both the givee and the takee. I'm not sure how to say that. How would you say it? I don't know. All right. I probably shouldn't write that down officially, but the subject and the what? Tester. I like that. Better than the takee and givee. Okay. Subject and the tester do not know. So my question is, in a double-blind experiment, who does know? Someone has to know. Okay. I can give you an example of how something might be considered double-blind. If we're looking at what Byron was suggesting with the placebo and let's pretend like it was, we're doing an experiment as to whether aspirin reduces the number of heart attacks. Okay. And you're giving someone an aspirin and one group aspirin and one group a placebo. And I put all the aspirin in a red jar, and I personally put all the aspirin in a red jar and all of the placebos in the blue jar. And then I asked Cameron, here's a red jar and a blue jar. Give everyone in group 1 a pill out of the red jar, and everyone out of group 2 a pill out of the blue jar. That's a double-blind experiment because Cameron has no idea what's in each jar. She's just told to give one in each. People taking it don't know. But who does know? The person that's designing the experiment, okay? So it's kind of like the middleman doesn't know. Does that make sense? Sort of. You what? Maybe. Sure. Okay. So blinding is something that you want to take into consideration. Why might that be something that's important to do? Why do you think we should use blinding when we do an experiment? Yeah, If you know that you're getting a placebo or you know you're getting the aspirin, do you think maybe you might convince yourself that you're having a heart attack, or I don't know, you think you are or something, right? I mean, you can convince yourself if you think if you know what kind of treatment you're getting, then that has an effect on the outcome. So blinding is a real important thing to use when it can be accessible. Not always in every experiment can you do it. Okay? Vocabulary-wise, any questions? No? So what makes a good experiment? Okay? There's really only 3. I'm going to highlight what the 3 words are, and then we'll get to the other ones in a few minutes, okay? So, 1, 2, and 3. So these are the key elements to a good experimental design. If I'm going to design an experiment and I want it to be well designed, you must include all 3 of these. I say sometimes there's a 4th element, and that 4th element's called blocking. And I'll put sometimes 4 in a different color, because if you can use it, do it. But sometimes it can't be done. Okay? So randomization. It's very important that you understand how randomization is used. So I'm going to give you an example. Is this considered randomization? Or is it, I should say it this way. Let me ask the question. If you have people that want to volunteer to be a part of your experiment, is that a problem? Yes. No. Why not? Because what you do is you take the people that are going to volunteer for your experiment and you use randomization because you do what? You randomly assign them to the treatment groups. So if I'm using Byron's example of the placebo versus the aspirin, and I say, okay, this group of people volunteered, I'm going to assign everybody a number and say all the odd numbers are going to go into the aspirin group and all the even numbers are going to go into the placebo group. So I've randomly assigned them to treatment groups. That's how randomization is used here, okay? You don't need randomly to go out and select people, because you can't really, because a lot of times experiments, like it's people that have heart problems or people you have to use. So you can't randomly pick people. What if they don't have a heart problem? Then it doesn't work that way. So you have to have people volunteer for the experiment, but then you randomly put them in groups, okay? 2, control. We've already kind of talked about that, but we haven't called it a control. What's a control? What's an example of a control that we've already discussed? What is a control? The placebo would be an example of a control. It's a control group is somebody that doesn't get the treatment. There is no treatment, or there's a placebo. That would be a control group. So there's just no treatment, or there's a fake treatment. Either one would be considered the control group. Okay? And you need a control group to act as a comparison. Sometimes people act as their own controls, and we'll talk about that after your quiz on Monday. Okay? Now, replication. Replicated. Sounds a lot like repeated, doesn't it? Okay? There's 2 kinds of replication, and one's a lot easier to do than the other. The first kind of replication means if you have these treatment groups, you have your aspirin group and you have your placebo group, you have more than one person, or you have, 20 people in each group. That's a form of replication. The number of people in a treatment group is large enough. Okay, that's considered replication. You just don't want one person that takes aspirin and one person that takes a placebo, and there's your experiment. That wouldn't satisfy this element. So replication means in each treatment group you have a number of people. The other kind of replication would be when you just repeat the whole experiment. Okay, you do the experiment more than one time. Why might not that be reasonable? Time, money, both of those are really the issue, right? Sometimes it takes a long time to do an experiment, and obviously cost is a big factor. Okay, so that's a big issue. Now, what's this blocking thing? Well, if you can block, it means that you are trying to reduce some other variable that could influence the results of the experiment. Here's an example. Back to the heart medication, or the aspirin versus placebo. What is an example of a variable that might have an effect on that? Who would maybe, what kind of people, that sounds weird, but is there a group that might respond differently to a treatment than others? People that are allergic to aspirin, obviously you just wouldn't want to include them in this type of experiment at all. I agree. What conditions, though? Be more specific, Katie. Okay, if you have a heart condition versus if you don't, I think we want everybody who had a heart condition to be in the experiment. But even so, what about women versus men? Aren't there more, actually, isn't there been studies done that more women have heart attacks than men do, actually? They suffer from heart. Men might be resistant to something versus women. So how women versus men react towards medicine or the treatment might be different. So that might be a reason to block. And actually, gender is often is a type of blocking that we use. It's often used. Did you have a question, Cameron? Race, absolutely. Some people race-wise would have the same effect, right? So one race might be more prone to having heart disease versus another, and that actually has been studied and shown. You're exactly right. So these are just things you want to think about. Blocking reminds me a little bit about what kind of sampling that we talked about. Stratification, a little bit, right? It's a little similar. We just want to make sure that we're putting people in like groups so to reduce that idea of variables there. Okay? Now, this isn't written very large, so I'm going to make it larger. Oh, God, you scared me. Okay, I was like, where did she go? But I put it in a star to try to make it larger, but we'll make it really big. Yeah, whatever. This is important. Sure. Highlight it, star it, circle, make it sparkle, make it shine. I love it, okay? Oh, good grief. Just be happy. This is so important. It's so important that I'm starring it a lot. All right, you get the idea, okay? Remember that sentence we did with bivariate data, and we said just because two things are correlated to each other, that doesn't mean one causes the other to happen? Do you remember that? Remember the firefighter example I gave you? That the correlation between the number of firefighters at a fire and the strength of the fire are strongly correlated to one another, but that doesn't mean that firefighters cause fires. Remember that example? So just because things are correlated, one doesn't cause the other to happen. But guess what? Experiments, as long as they're well-designed experiments, and we should probably add that, because you have to have all the components to a well-designed experiment. But if you have a control group, if you have replication, if you have randomization, then you can say that one thing causes the other to happen. In our heart disease example with the aspirin versus the placebo, if I design it well and I use randomization, I'm even going to use blocking because I don't want gender to cause an issue or race to cause an issue. So I'm going to block by those things, and then I'm going to go ahead and randomize the treatment groups, and I'm going to use those well-designed aspects. I can then come up with a conclusion based on my results that could say aspirin prevents heart attacks. And that can be said if I do the experiment and my results show that. Okay? So that's the only thing that can show that relationship. It's a pretty big deal. Has to be an experiment. What makes it an experiment again? if it gets given a, no, that's well designed. And that's, it's well designed, I agree. It's got randomization. But any experiment, what if it's a cruddy experiment? It's at least got to have a what? Begins with a T. Treatment. Okay, it's got to have a treatment to make it an experiment. All right. So here's an example for us to do. This is how we're going to end today. Okay? I've got 80 people that are volunteering to join a weight loss study. I want us, this is kind of like an example, a problem that we're going to do, to design an experiment using all the elements of good experimental design that we know. Yeah, this is your kind of like the problem that we're going to solve today. And we're going to use Jenny Craig, Weight Watchers, and Nutrisystem. And we're going to design it. We're actually going to diagram it. We're going to draw it. And we're going to explain what we're going to do. So once you read the problem and write it down, the first thing I want you to decide is how many treatment groups we're going to have. More than 3. Maybe 4. There's at least 4. Okay. If we're going to block, there'll be more than 4. Okay. But there's at least 4 treatment groups. I think we should probably block by gender. Okay. Because I think that males might respond to a different weight loss program a little bit differently than women do. And I know this for a fact because I've done them all. And Weight Watchers, they get more points than we do. And in Nutrisystem, they get to eat more stuff. It's not fair. Anyway, so I know that men and women, they respond to weight loss differently. Absolutely. Age, there's lots of other different issues we could talk about. You could block by a lot of variety of things, but let's just do gender for today. Okay? So what I think we should do is when you are blocking, that's really where you start. So let's create 2 blocks of males and females. Okay? So we're going to block by gender. And that's, you all, if you're going to block, you do that first. Okay? Now, within each block, how many treatment groups are we going to have? James, we're going to have 4. So from each of, and by the way, have you seen these? I've used these symbols before, haven't I, for male and female? I think I have. The top one's female. The bottom one's male. So I'm going to draw 4 little lines out of each of them. Okay? First of all, before I even go any further, how many females and how many males do I want? If I have 80 people to start with, I want to divide it evenly. So I really want to have 40 females and 40 males. Okay? And I can't do randomization yet because I can't randomly tell you if you're a boy or a girl, right? So randomization isn't there yet. But once I get my 40 women and my 40 men, can't I randomize now? Now I'm going to randomly tell you what treatment group you're going to be in. And so that's where you're really going to say in your diagram that you're going to randomize. So you'll kind of see it written like this when you diagram. You're going to randomize who goes into what treatment group. We have to kind of explain, well, how many people go in each treatment group here? 10. Good. So we know that much. So we know we're going to put 10 in each of these treatment groups. But we still have to explain, first of all, what the treatment groups are and how we got them there. So what are the treatment groups in each? Cameron? We have Jenny Craig, Weight Watchers, Nutrisystem, and the control group, right? Control group or the placebo group. Good. We got that control group. And in this case, I don't think it's feasible to use a placebo because you just say just regular diet, no diet. There's no treatment there, okay? So it's people that aren't on a weight loss program. Does that make sense? Okay? Because you can't say, oh, here's a fake Jenny Craig diet. Like, that doesn't make sense. Like, you know if you're counting points or not, right? Okay. So at least I've assigned my treatment groups, but now I have to explain how I randomly picked 10 of each. So we know we blocked by gender. That was the first thing we did, and we put 40 males and 40 females. Now, the second thing I'm going to do is randomly assign treatment groups. So how do I do that? So if I'm going to randomly assign 40 males and 40 females to treatment groups, let's explain that process. This sentence enough is not thorough. It's not going to get you full credit. You have to explain that randomization process. So what would that process be? Well, we've already blocked by gender. Katie, got a suggestion? Sure. So let's assign 0, 1 to 40. Would you agree with that? Okay. So we're going to say we'll start with the males. We'll assign 0, 1 to 40 for the males. And then what are we going to do? Either use a random table. Why don't we use a calculator here? Would that make it easier? Because we don't have to worry about it. We can ignore repeats. Wouldn't we have to ignore repeats? We don't have to ignore any other numbers. So we're going to use the random integer calculator on our function on the calculator. So it's going to be rand int 0, 1 to 40. Keep writing this down. 40. Okay. And we're going to ignore repeats. So if I randomly do that, what am I going to do? The first 10 numbers that come up are going to go where? Jenny Craig? I don't know. Doesn't matter. They can go anywhere. I don't really care. So we'll just say the first 10 numbers go to Jenny Craig. The next 10, again, we're ignoring repeats, right? Once they've been assigned to a treatment group, they can't be in both Jenny Craig and Weight Watchers, right? So the next 10 are going to go where? Pick one. I don't care. Weight Watchers. Go to Weight Watchers. The next 10 go to Nutrisystem. And the remaining 10 will be our control group. I think I spelled remaining wrong. I sure did. Okay. And then we'd have to repeat this same process for females. You could use the same numbers, it doesn't matter. I could, if I wanted to do 41 to 80, that would be okay, perfect, that would be fine. But I've already picked the males, so now I'm just going to do the exact same process. I'm going to assign all the females, 0, 1 to 40, and do the same thing. So it doesn't really matter that they're numbered the same, because they're two different blocks. Okay? Now, the last thing I have to say here is once I've assigned them their treatment groups, what am I actually trying to do at the end? Compare them. Aren't I comparing all of them? And aren't I measuring something to see if they lost weight? Right? I'm trying to do something. So at the end, you're going to compare within each block. I'm going to compare all the men, and I'm going to compare all the women. And I can compare men to women, and sometimes you do that, but you really should compare within each block because you think that men are going to respond differently than women. That's why you block them to begin with. Okay? So you really are going to be comparing there. So when you read this chapter, you'll see some of these diagrams drawn this way. Okay? And I just wanted to make sure that we did an example like that so you could see. Okay? So what do you have to do before next class? Okay, so you have two things. One, you have to study for your survey quiz, and it's chapter 11. And then 2, I am going to go ahead and have you read chapter 12. It is on experimental design. There will be some vocabulary, a lot of what we talked about today, and I want you to do the just checking. Okay? So that's what I'll be looking for next class. You have a quiz, and then the just checking in chapter 12. Fair enough?